Set generative design objectives. In this video, we'll set a generative design objective, modify generative study settings, set a material, and we'll manage physical materials. In Fusion 360, we want to carry on with our generative design geometry setup. At this point, we have all of our loads and constraints set up, and we need to begin defining the objectives needed to set up and run the generative study. At this point, the preserve and obstacle geometries, the loads and constraints, are only a piece of the puzzle. The next thing that I want to do is go into my study settings and take a look at some options that we have. First, I want to note the resolution. The mesh resolution is going to have an effect on how long it takes to calculate the results. Setting it closer to fine makes the mesh elements much smaller and means that the calculation times will take a bit longer. The benefit to this is that the mesh resolution being smaller means that the outputted geometry that we get is generally going to be much smoother. There is an inverse relationship here, of course. If we go to a coarser mesh, in this case, that coarser mesh is going to calculate much faster, but the end results might not be as aesthetically pleasing. That doesn't mean that the results are bad in any way, but we have to manage our expectations between the mesh resolution and the calculation time. In this case, I'm going to set the mesh resolution about 50%, and note that we have a couple options. We have alternative outcomes and remove rigid body modes. The alternative outcomes was part of that preview functionality, which we can include. In our case, I'm not going to include that, and the inertial relief is not needed in this case because we have completely fixed the frame and we're loading the front and the rear suspension. But those additional options can help us depending on what geometry we're trying to define. The next thing that we need to do is take a look at our design space. While we didn't include a starting shape, it can oftentimes be extremely helpful to have a starting shape to define the build volume. There are certain instances where a design requires a starting shape. In cases where some of our preserved geometry is completely obscured by obstacles, it might require a starting shape in order for us to actually get a solution. Symmetry plane can be extremely helpful, and in our case, because we do have somewhat of a symmetric geometry, we could use a symmetry plane. There is one potential problem here in the fact that the frame mounting lugs are actually not symmetric to the midline of the motorcycle. So for our example, we're not going to be using symmetry plane, but it is extremely helpful in some cases. The other option we have is something called obstacle offset. Now, in some cases, the obstacles we define are exactly the size of the things we're trying to avoid. In other cases, we might want to make them a little bit larger. Even though we have obstacles, it is not uncommon for the generative design solution to build into those obstacles, and then once a design is created, they'll be removed. So if that's the case, oftentimes it's helpful for us to extend the size of our obstacles. In our case, our obstacles are so general and generic for the gas tank and the frame that we're really not looking at these tight or very specific areas. So we're going to leave this option off as well, but just note that it is extremely helpful in some cases. So now that we've explored the design space, as well as some of the design conditions for our loads and constraints, let's talk about the criteria. There are two main things that we need to talk about with criteria, and in this video, we're going to focus on the objectives, and we'll cover manufacturing methods in another video. The objectives here are going to help us determine what condition means a convergence of our results. So when we have a generative design study, it's going to simulate each of our load cases for each material, each manufacturing method, and it's going to target our objectives and our limits. So when we're looking at our objectives and our limits, we can look at minimizing the mass or maximizing the stiffness. Now, if we're going to maximize the stiffness, we can have a mass target. In our case, if we want a relatively light frame, we need to shoot for something that is a relatively small mass target, say 0.35 kilograms. When we're talking about the mass, that 0.35 kilograms, that is a relatively small and light frame, much lighter than anything that you would find on a production motorcycle. But the benefit of using generative design is that we can explore this as an option without having to design and validate and redesign and revalidate over and over again until we get closer down to that iteration. What oftentimes happens with production parts is they'll make a generational change. They'll design a part, it might be overbuilt, it might have a lot of extra mass, and in the next generation or the evolution of that product, they'll begin to start to do what's called lightweighting. They'll begin removing some of that mass because they now have data that can support it. For our frame, let's use something a little bit more conservative. We'll use 0.5 kilogram, which is still an extremely light frame. Note that we also have some additional options, things like modal frequency. If we're worried about the vibration of the engine, we can use modal frequency. If we want to dictate the maximum displacement that the frame can have. This can be extremely helpful in the case of a frame because we're talking about minimizing the deflection and then the geometry change that happens with it. We also have a buckling option. Once again, the buckling, the displacement, the modal frequency, these are very specific types of objectives and limits. So for our example, we're going to use maximize stiffness, a safety factor of 2.0, and the mass target of 0.5 kilogram. Once we have those set, notice that our pre-check is still telling us that we don't have everything. Some of the default settings for manufacturing methods include 3D printing, which is not a really applicable option for this motorcycle frame. And also note that we really haven't gone in and talked about the materials at all. So there's still a lot for us to set up and define. Let's make sure that we save the design before we start to explore our materials. Once our design is saved, let's navigate to the materials section. Even though we're skipping over manufacturing methods, I do want to talk about our study materials and the way in which we define them. Right now, the methods is set to all methods. The methods that are shown here are only going to be the methods that are included in our manufacturing methods. So currently, by default, unrestricted, additive, and milling are defined. What we can do in here is we can set up materials that are specific to the manufacturing methods, or we can set them up for all methods in general. When we take a look at the library section, we have the additive material library. It's important that we use the material library that's applicable to the manufacturing method that we're going to use. The reason that's important is because there are materials in here, for example, in the additive library, that are specific to the DMLS or the metal manufacturing process. This also helps us understand which materials have cost estimation built in. Cost estimation is extremely helpful, especially for certain materials, but notice that not everything has it. So for our example, we're going to go to the default Fusion 360 material library, and we're going to go into metal. We want to explore this frame as an aluminum frame, but we also want to explore it as a steel frame. So we're going to drag that aluminum material up into the upper section of In This Study, and then we want to scroll down in our metal library until we get to our steel materials. When we're taking a look at these materials, the material properties or the manufacturing methods that were used to strengthen the materials are going to be extremely important. For our examples, we're going to be focusing on aluminum as a base material and steel as a base material, but then we're going to go back to the aluminum section and we're going to pick out a 6061 and we're going to pick out a 7075. So there are a couple different materials and ways that we want to consider this, but we'll take the 6061-0, we'll take the 7075, and at the very end, we want to make sure that we include the A356T6. It is important to note that there are limitations to the number of materials that you can select. Currently, you can have at least 7 materials, but that's going to be over the entire generative design study. So if one of your manufacturing methods has 7 materials chosen, then it's going to be problematic, so make sure that you do pick wisely. It is also important to note that the more materials you choose, the more results you'll get, but also the longer those calculations will take. So at this point, let's make sure that we save this design before moving on.